Okay, conjecture number one. If two angles form a linear pair, then the measures of the angles add up to 180 degrees. So what we want to show here is we want to show that these two angles, and I'm using here the marker tool, if you click on the vertex of the angle and you drag into the angle and then let go of the mouse, look at the angle. If you click it one more time, it'll have two arcs, and then here it has one. Once you have your two different angles, you can highlight those arcs and go to Measure Angles. You have your two angle measures. You can then move point D and see how those angles change. What we want to show here is that if we go to Number, Calculate, if we add these two angles together, that their sum will always be 180 degrees. So no matter how this moves, the sum is always 180. Conjecture number two, the vertical angle conjecture. If two angles are vertical angles, then the angles are congruent. So what we want to show here again is we want to show that, let's just say that the top and the bottom angle are congruent. So I'm going to mark these vertical angles, measure angles, and I can see here that no matter how the lines or segments intersect, that those vertical angles are always congruent. Conjecture number 3A, if two parallel lines are cut by a transversal, then corresponding angles are congruent. So what we're going to do here is just mark two corresponding angles. We're going to measure those angles, measure angles, and show that corresponding angles are in fact congruent. We also want to show that the lines are indeed parallel. So if I highlight these two segments and go to Measure Slopes, what you can see here is that the slopes are going to be the same. So as I move these lines here, you can see that the slopes are the same, so the lines must be parallel. Conjecture 3B, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So we're going to go ahead and mark alternate interior angles, measure the angles and show that those are congruent. Again, we want to show that the lines are also parallel, so measure slopes. And as you're using the marker tool, if you get extra arcs, you can always just keep clicking and then it will reset. Conjecture 3C, alternate exterior angles. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So we want to mark alternate exterior angles here, measure those, show that those are congruent, and then also show that the lines are parallel. Okay, so no matter what those angles are, the slopes are always going to be the same. And then lastly, conjectures 3 and 4, they go hand in hand. Conjecture 3 states if two lines are parallel or two parallel lines are cut by a transversal, then corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. So let's show that. So we want to show that we have corresponding angles that are congruent. We want to show that we have alternate interior angles that are congruent. And lastly, we want to show that we have alternate exterior angles that are congruent. So if all these angles are equal to each other, then we know these lines must be parallel. Okay, so it goes both ways. One conjecture number 3 states if the lines are parallel, then you know that corresponding angles are equal. You also know that if the lines are parallel, alternate interior angles are equal. And lastly, if the lines are parallel, alternate exterior angles are equal. The converse of that states that if you know that you have corresponding angles that are equal, then the lines must be parallel. If you have alternate inside angles that are congruent, then the lines must be parallel. And then lastly, if you have alternate exterior angles that are equal, the lines must be parallel. Okay, so you can use the same sketch for 3 and 4.